This is going to be a vodcast on catalysts and intermediates. So there's not really any math on this, just a lot of concepts in being able to identify an catalytic or intermediate in a reaction mechanism. So a catalyst is a substance that speeds up a reaction without it being used up in a reaction. For those of you who remember from biology, enzymes are perfect examples. Enzymes are biological catalysts. There's two different type of catalysts. A homogeneous catalyst are in the same phase as the reactants. So if you're mixing two liquids together, a homogeneous catalyst will be the same phase, so it'll be a liquid as well. A heterogeneous catalyst is when the catalyst is in a different phase. So for instance, if you're mixing two liquids together, the catalyst may be a solid that you throw in there to make the reaction go faster. So allows reaction to proceed by a different mechanism. Basically, it's a new pathway. This new pathway has a lower activation energy than the original. And more molecules will have this activation energy. So the big key point is that does not change the delta E in the reaction. So let's take a look at basically a graph of this. So here we have a reaction progress. So as the reaction is proceeding, we always begin with reactants and eventually it'll form products. The y-axis is the amount of energy that's needed for that reaction. So here we have a reactant that has a certain amount of energy, and after the reaction has proceeded, it has actually gained some energy in the process. The red line is when the reaction is uncatalyzed. So if you see here, it takes a lot of energy for this reaction to proceed, for it to turn into a product. If you throw in a catalyst, whether it be heterogeneous or homogeneous, what it does is it actually lowers the activation energy. So it takes less energy for this reaction to proceed than before. So this is the big difference between how you can identify a catalyst in a reaction mechanism. It lowers basically the hump of the activation energy. As it said in the previous slide, it does not change delta E. So this segment right here does not change at all, if you can see. All it does is change the amount of energy needed for the reaction to proceed. So please commit this to memory, the way catalyzed are exhibited on a graph. So the last thing is intermediate, and basically an intermediate is a species that is neither a reactant nor a product, but that is formed and consumed during a reaction sequence. So let's show by example. Oops, let me make this a little bit bigger. All right, so here we have basically the destruction of ozone. So here we have, or forming oxygen. O3 ozone reacts with an oxygen intermediate or oxygen radical, what we call it, to form oxygen. So this is basically the reaction of the destruction of ozone. Here we have a possible proposed mechanism for ozone destruction, and it happens in two steps. So the first step is the slow step, second step is the fast step. If you notice, O3 reacts with this chlorine radical. Now, where the heck did this chlorine radical come from? That is your catalyst right here. This is something that's consumed in a reaction, and it's always going to be in the reactant side on the step one. And in the end, it eventually turns into the product. So when you add these two reactions, if you notice, there's no chlorine on either side of the reactants or products. This is the true definition of a catalyst. Catalysts always show up in the reactant side in step one, and somewhere along the process, it'll also show up in the product side. So again, when you add the two reactions, you notice that there's no chlorine in there whatsoever. That's how you can identify a catalyst. This one right here is an intermediate. Intermediates are always going to be somewhere in the middle of the reaction mechanisms, so whatever step it is. So if you notice here, O3 reacts with chlorine to form O2, and then we have this chlorine oxide radical right here. So this is my intermediate. It's in the product side. It's never going to be in the reactant side, especially in step one. And here, in step two, what was produced in step one got consumed in step two, and is no longer there as well. So if you notice, the chlorine is not longer in my reaction. Neither is the CLO is not in there. Same with the Cl. So the boxed ones are my catalyst. They get consumed and disappear after you add them up. And your intermediates are produced but also consumed in another step, but they never show up in the overall reaction. And this is how you're able to identify both of those when if you're ever given a step-by-step mechanism of a reaction. All right, I hope that helps.